Hi, I'm Katie Martin, and I'm a master's student at the University of Maryland Center for Environmental Sciences Chesapeake Biological Laboratory. I work in the lab of Dr. Michael Gonzor on a project in collaboration with Dr. Andrew Hayes and Dr. Laura Harris. And we're trying to develop a method to tell if there's septic wastewater entering streams. We're studying the nutrients in the water, things such as nitrogen and phosphorus. We're studying the organic matter in the water, the molecules from things like plants and organisms living in the water. We are sampling 9 streams in Calvert County every month. When we go out in the field, we first take water quality measurements, things like pH, conductivity of the water, temperature. We also take flow measurements. Flow can help us better understand how different levels of things like rainfall change the level of contaminants entering the stream. We take large volumes of water, which we then filter in the lab to remove the non-dissolved organics, so we can look at the organics that are dissolved in the water. This can include things like different chemicals that can come from medicines and from the food that we eat and from the products that we use. We're also trying to identify how much nitrogen is being released from septic systems. Too many nutrients can cause things like phytoplankton blooms, which decrease the amount of oxygen in the water. This is bad for the organisms that live in the bay who need oxygen in the water to live. This is important to managers in the Chesapeake Bay region who are trying to understand the different sources of nitrogen entering the bay and ways that we can decrease them. We hope that our work can provide a better estimate of nitrogen that's being contributed by septic systems to the bay. This could have management implications in terms of whether areas that are predominantly on septic systems should be switched over to traditional sewer systems. So we're hoping to better understand the effectiveness of these systems in decreasing nitrogen that's entering the water body. I'm currently developing methods on instruments that we have in our lab to try to measure these contaminants in the water. We are combining this with isotopic measurements, which are specific kind of elements that can help us distinguish the source of certain chemicals. I'm currently looking at sweeteners that are in the water, things like sucralose and saccharin and isosulfame potassium. Sucralose is the dominant sweetener in Splenda. Some of the other sweeteners I'm looking at are common in things like Equal and Sweet and Low. Some of them are also known for not decomposing over a long period of time. The sweeteners that I'm looking at aren't necessarily harmful to the water. They're just known as good tracers that would show that septic is entering the water. There's many other different measurements that are going into developing this tracer, and we're hoping that some kind of ratio or combination of them may be the tracer for septic wastewater.